From the dawn of time, beneath a mystical night sky lit by myriad stars, a question has sprouted in the human mind. Who are we in this vastness? That question initiated the greatest journey of the intellect, the quest to explore the universe. It is a path that stretches from the first admiring gazes to theories that shook the foundations of perception, and it is still being written every day. Over 5,000 years ago, humans began to observe the universe systematically. The ancient Babylonians could calculate solar and lunar eclipses. But it was the ancient Greek philosophers and astronomers who laid the foundational bricks for cosmology. They did not just look to the sky to admire the great sun or the shimmering stars, but also grappled with questions of eternal significance. What is the universe? Why does it exist? From Pythagoras with his concept of a perfect spherical earth, to Aristotle and his early models of the cosmos, they turned wonder into science. That aspiration has never faded. Today, we have ventured beyond our atmosphere, taken our first steps on the moon, and are setting our sights on Mars. Technology has changed, but the curious gaze toward the sky remains as pure as it was at the beginning. Science, by its very nature, is a never-ending journey to expand the intellect, and we are only in the opening chapters. Among the countless questions about the universe, the question of its beginning has always been the greatest mystery, and the answer most widely accepted by the scientific community today is called the Big Bang Theory. This was not an explosion in space, but the very event that gave birth to space and time itself. The father of this theory is Georges Lemaitre, a Belgian physicist, astronomer, and also a priest. He called it the primeval atom hypothesis, envisioning the universe beginning from a single point, a cosmic egg. Initially, Lemaitre's idea sparked intense debate and was met with skepticism. The name Big Bang was actually coined by astronomer Fred Hoyle with derisive intent. But then, irrefutable evidence emerged. The expansion of the universe. In 1929, Edwin Hubble's observations showed that galaxies are moving away from each other. This was the first experimental evidence that the universe is not static but is expanding. To recognize the contributions of both, the law is known today as the Hubble-Lemaitre law. The cosmic microwave background radiation. Discovered by chance in 1965, this is the leftover light from a time when the universe was only about 380,000 years old. It is the faint echo of the Big Bang, a solid proof for the model of a hot, dense early universe. This model tells us that the universe originated from a singularity, a state that cannot be described by the conventional laws of physics, where space and time did not yet exist. It was at once everything and nothing. And right here, a great question resounds like an echo from the abyss. What came before the Big Bang? What lies beyond that singularity? From moment zero, the universe has undergone a miraculous evolution to create the world we know today. After the Big Bang, the universe was in an extremely hot state, then began to expand and cool. Basic subatomic particles like protons, neutrons, and electrons were formed. About 380,000 years later, the universe had cooled enough for electrons to combine with nuclei, creating the first neutral atoms, primarily hydrogen and helium, along with a small amount of lithium. The universe went from opaque to transparent. About 300 million years later, under the influence of gravity, giant gas clouds began to collapse, forming the first stars and galaxies. It was in the nuclear forges of these stars that heavier elements were created. When the universe was 8.8 billion years old, our Sun and Earth formed from the remnants of previous generations of stars. 3.7 billion years ago, the first life emerged on Earth, beginning a journey of evolution and proliferation that continues to this day. All of us, all the matter around us, are products of this 13.8 billion year journey, which began from a single moment. Science is not a faith, but a continuous process of self-questioning and evidence-seeking. Although it is the most successful model, the Big Bang Theory still faces major challenges and questions, especially from the latest data. The cyclic universe hypothesis. In 2010, Nobel laureate physicist Roger Penrose proposed that our universe might be a repeating cycle of birth and death. He suggested that anomalous concentric circles in the cosmic microwave background could be traces of supermassive black holes from a universe that existed before the Big Bang. Is the Big Bang a singular beginning, or just one bounce in an infinite series? The Hubble tension. This is one of the most vexing problems in modern cosmology. The two main methods for measuring the expansion rate of the universe, one based on the early universe and one on the nearby universe, yield two results that do not match. This discrepancy, though small, could indicate a flaw in the standard model of cosmology. Discoveries from the James Webb Space Telescope. Since becoming operational, JWST has sent back astonishing images. It has discovered surprisingly mature and complex galaxies in the very early universe. This does not overthrow the Big Bang, but it challenges our models of how quickly galaxies form, suggesting that things may have happened faster than we thought. We can only observe a part of the universe, at most 13.8 billion light-years away. Curiosity never stops, just as the universe itself is constantly expanding. Science is a journey of humility. What is considered truth today may be supplemented or revised tomorrow. Humanity's deep understanding of the universe has only really developed in the last few hundred years, a moment like a single second in a human life compared to the 13.8 billion year age of the universe. This very humility is the most powerful engine driving knowledge forward. The future of the universe might be a bleak big freeze, as it expands forever until every star has died out. But that is a story for tens or even hundreds of billions of years from now. For now, we have at least a few billion years to exist, to learn, and to explore. The story of the universe is never over. It has only just begun. And we, the people sitting here, are the ones writing the next chapters in that great chronicle. The journey to explore the universe is a common adventure for all of humanity. Every question asked, every mystery unveiled, brings us closer to our own origins. Let us continue to look up at the sky, to keep asking questions, and to never stop wondering. Because the journey to explore the universe is also the journey of discovering humanity itself.